Hi everyone, welcome to CodeChef. In this video, we are learning about increment operators, special operators that increase a variable's value by 1. These might seem simple, but understanding when and how they work is crucial for writing loops, counters, and efficient code. By the end of this video, you will understand the difference between post-increment and pre-increment, and you will know exactly when to use each one. Follow along with me and practice on CodeChef. The link is in the description below. Before we dive into specific operators, let's understand the concept of incrementing. To increment means to increase a value by 1. It's one of the most common operations in programming. You could write x is equal to x plus 1, which means add 1 to x and store it back. Or using compound assignment, x plus is equal to 1, which is the shorter version. But in C, we can write it in an even shorter way, which is x plus plus. This single operator does the same thing, adds 1 to the variable. Here's where it gets interesting. C has two increment operators. Post increment x plus plus, which uses the value first, then increments, and pre-increment, which is plus plus x, which increments first, then uses the value. The difference is subtle but important. Let's explore each one in detail. Let's start with post-increment operator, which is written as x plus plus. The word post means after. So, post-increment means the increment happens after the current value is used. Now let's see how it works. First, the current value of the variable is used in the expression. Then, after it's been used, the variable is incremented by 1. The syntax looks like variable plus plus, same as variable is equal to variable plus 1. Now let's see this in action with a clear example. Here we've included the standard input-output library. Now here is where our main function begins. Int a is equal to 5. Here we declare an integer variable and a initializes it with value 5. This is our starting point. We'll watch how this value changes through the post increment operator. Our next line of printf prints the initial value of a before any increment happens. A currently contains 5. So here output will be before 5. This establishes our baseline. We know a starts at 5. Our next line is the key line where post increment happens. Let's break this down very carefully. The expression a plus plus uses post increment. The current value of a, which is 5, is used first in the printf statement. This value is passed to %id and printed. After the value is used, a is incremented by 1. Now a contains 6, but we've already printed 5. So the output for a plus plus is 5. Even though a plus plus increments the variable, we see 5 printed. This is because the old value was used before the increment. After this line executes, a contains 6. The increment has happened. This is the essence of post increment. Use the current value in the expression and the increment comes afterward. Now we print a again to see the effect of the increment. After the previous line, a was incremented. Now a contains 6. So the after output is 6. This confirms that the increment did happen. It just happened after the value was used in the previous printf statement. Now return 0, which means our program ends successfully, and our closing bracket. When you run this, the output is before 5, a plus plus 5, and after 6. What we must remember is that a plus plus The increment happens after the value is used. Think of it as show me what you have now, then add 1. Now let's see a practical example where post increment is perfect, a library book issuing system. In a library, when books are issued to students, we want to show the current issue number, then increment the counter for the next student. Post increment is ideal here because we want to display the current count before updating it. Here we include our standard input-output library. Our main function starts here. Now, we declare an integer variable issue count and initialize it with 0. This will keep track of how many books have been issued. Starting at 0 makes sense because no books have been issued yet. This comment explains what we are about to do. Issue books and print the issue number. Now, let's look at the next statement of printf. We carefully analyze, and what happens here is that when student A gets a book, the current state of issue count is 0. The expression issue count plus plus uses the current value 0 first. This value is passed to %id. It prints book issued to student A, issue number 0. After printing, issue count is incremented to 1. So after this line, issue count is now 1. Line 8 printf statement tells about the student B who gets a book. So our current state of issue count is 1 from the previous increment. The expression issue count plus plus uses the current value 1 first and prints book issued to student B, issue number 1. Then increments issue count to 2. After this line, issue count is now 2. Student B gets issue number 1. That is how it should be. Now, here is student C's turn. The current state issue count is 2. The expression issue count plus plus uses 2, prints it, then increments it to 3. So, book issued to student C, issue number is 2. Our next printf statement is where student D gets a book, where issue count is 3. The expression issue count plus plus uses 3 to print it, then increments to 4. Now, at return 0, our program ends, and at this point, issue count would be 4 if we checked. Our closing bracket, and now let's try running the program. When you run this program, the complete output is book issued to student A, issue number 0, book issued to student B, issue number 1, to C, issue number is 2, and to D, issue number is 3. We started at 0, after student A it became 1, after B 2, C 3 and D and at 4. This is perfect for a sequential numbering system. Each student gets a unique issue number and the counter automatically updates for the next person. What we should remember is that post increment is ideal when you need to use the current value and then update it. Now let's learn about the opposite, pre-increment operator, which is written as plus plus x. The word pre means before, so pre-increment means the increment happens before the value is used. And how it works is that first the variable is incremented by 1, then the new incremented value is used in the expression. Think of it like update first, then use the new value. The variable is plus plus variable, same as variable is equal to variable plus 1. The key difference from post increment is that x plus plus uses the old value, then increments, and plus plus x increments first, then uses the new value. Now let's see this with a clear example. Here we include our standard input-output library. Our main function begins here. We declare an integer variable x and initialize it with the value 7. So this is our starting point. We'll see how pre-increment changes this value. This is a comment that explains what's about to happen. Pre-increment means x is incremented before it's used. Now this printf statement is a crucial line. Let's understand pre-increment very carefully. The expression plus plus x uses pre-increment. X is incremented first before being used. So the current value, which is 7, after increment becomes 7 plus 1, that is 8. Now x contains 8. The new value 8 is used to print f statement. This value 8 is passed on to the percentile d and the value 8 is printed. We see 8 printed, not 7. This is because the increment happened before the value was used. This is the essence of pre-increment. Increment the value first, then use the new value in the expression. If this were x plus plus, we would see 7 printed, the old value, then x would become 8. Let's see a real world scenario where pre-increment makes perfect sense. A game level up system. When a player levels up in a game, we want to increase their level immediately, then display the new level. Pre-increment is perfect here because we want to show the updated level, not the old one. So here we have included the standard input-output library, and here we have included the int main where our main function is. We declare an integer variable level and initialize it with 3. This represents the player's current level in the game. Let's say they are at level 3 and about to level up. Now, this comment explains the strategy. Increase the level first and then display it. Here. So this is where the level up happens. Let's analyze this carefully. The expression plus plus level uses pre-increment. The player levels up, level is incremented first. So the current value, which is 3, after increment becomes 3 plus 1, 4. Now level contains 4. The new level 4 is used in the printf. The value 4 is passed to the percentile d. We want to announce the new level, not the old one. It wouldn't make sense to say player level up to 3 when we already are at level 3. With plus plus level, we immediately show the new level, which is 4. Now in the next statement of printf, we print the current level to confirm. Level contains 4 from the previous increment. This confirms that the player is indeed at level 4 now. Both print statements show the same level because the increment already happened in line 7. Next is return 0, which means our program ended successfully, and our closing bracket. When we run this program, the complete output should be player leveled up to 4 and current level 4. So initially we started at 3, player's initial level, at line 7 with plus plus level incremented to 4 first and then printed 4. At line 8, still 4, no change. So when the player needs to see their new level immediately when they level up, pre-increment gives us the updated value right away, and post-increment would show the old level, which would be confusing. Now you must be wondering, when should I use pre-increment and when should I use post-increment? Let me give you a simple guide. Use post-increment when you need the current value first, then want to update it later. For example, sequential numbering, using the current count before incrementing and displaying the 4 values. Use pre-increment when you need the updated value immediately. For example, level up systems, immediate count updates, and when the new value is what matters. They are the same if you're just incrementing a variable on its own line, not in an expression, but both do the same thing. Pre-increment just increments x and post-increment, same result. Here's a memory tip. Post means after, uses the value, then increments, and pre means before, first increments, then uses the value. Let's recap what we learned about increment operators. Post increment uses the current value first, increments after using the value, and is perfect for counters, sequential numbering, and before values. Pre-increment increments first, uses the new value, and is perfect for immediate updates after values and level ups. The timing of when the increment happens relative to when the value is used. On a standalone line, both do the same thing, and in an expression, the timing matters. Both operators add 1 to the variable and are shortcuts for x is equal to x plus 1. These are used constantly in loops and counters. You'll see that soon.
Great job! You now understand the difference between post-increment and pre-increment. Head over to CodeChef and practice both operators. Try writing programs that use each one and observe how the timing affects your output. Keep practicing, keep coding, and I'll see you in the next one.